All right, let's begin. Welcome, everybody. I'm Dr. Waite. You probably are expecting to see Dr. Zatar, and he is the instructor for this class. But this week is attending a conference for the Transportation Research Board. So Dr. Zatar and pretty much every other transportation-related faculty member in the country is in Washington, D.C. this week. It's a big conference. Sometimes they have more than 30,000 people there. Probably this year it's less, though, because of COVID. I imagine some people may be joining remotely. In any case, I've taught this course a couple of times in the past, and so I volunteered to cover for him this week, and then he'll be back in class next Tuesday. So you'll see me today and also Thursday. Everybody's here for engineering economy and cost analysis, right? Engineering 222. How many people in here are engineering students? So most of the hands are a yes, but there's also some computer science students as well, right? So this is an engineering class, but it's about more than just engineering. We'll talk throughout today as a course overview of what's the purpose of this class and why are some of you non-engineering students in an engineering class. So I'll get into all of that today. But before I do, I'm going to take roll. Dr. Zatar is including an attendance component in your final grade this semester. So let me just go through this really quick and make sure that I've got everybody marked down for being here today. So just say here when I call your name. Jacob Ashworth? Here. Matthew Atwell? Emmanuel? Here. Matthew Barker? Here. Kent B? Here. Let's see. So Emmanuel wasn't here, and I marked him as yes. All right, Kent B, yes. Carrie Cochran? Here. Oh, Emmanuel is here. Okay, sorry about that. All right. Trey? Here. Colin? Here. Claire? Here. Noah Gray? Here. Tathan? Right here. Tyler? Here. Ali? Here. Owen? Here. Chris? Here. Nathan Lanham? Here. Isaac Lucas? Here. Blaine? Here. Connor? Here. Carly? Here. Boy, it's good so far. We're on a roll. Ethan O'Malley? Here. Braden? Here. Elaine? Here. Marco? Here. Chandler? Here. Lan? Here. Lon? Haley? Here. 100% attendance. I don't believe it. I don't think I've ever been in a class where everybody was here on the first day. Usually you've got some straggler who says, oh, I'm sick, but really they're in Florida. So good job for everybody being here. Hopefully it stays that way through the whole semester, because having taught this class before, I'll give you the secret to success right here at the beginning. It's just showing up. None of the things you're going to learn this semester are that complicated. This is not Calculus 2, right? Calculus 2 being a pretty complicated class. This isn't that. But this is a class you probably won't do well if you stop coming. So if you just get complacent or you allow yourself to become distracted, texting during class or zoning out, then there will be tears when grades post at the end of the semester. All right. So class number 1, this is the 11th of January, and what we're going to cover today is a discussion of what is money. We'll start with that. Since this is a class that largely discusses money, we might as well start with the real basics. And then we'll talk about something that's known as the time value of money. And that's kind of the heart of this course, is accounting for how money changes over time. And then we'll finish with the discussion and the in-class exercise where you'll do some problem solving related to interest. And then at the very end, I'll give you a copy of the syllabus and we'll talk about that. So any questions before we get started? No? Okay, so let's make a list. I want to just briefly, not spend a whole lot of time, but I want to know about, as a consumer, every person is a consumer and a producer, hopefully, but as a consumer, what are some goods and services that you're going to use today? And the reason why we're going to make this list is I think it will illustrate the purpose of money and how money is valuable. So let's just briefly add to this list. So tell me about what is a good or a service that you're going to use today.
Gas.
Okay. Gasoline?
Food.
Food?
Electricity.
Electricity? Let's see if I can spell that right. Well, that's not right, but, oh, that's so bad. Electricity. Oh, man. There we go. Thank you, autocorrect. All right, what else?
Computer.
Computer? I'm not sure why the lights just went off. What about services? Are you going to use any services today? Let's go with medium lights if we can. Oh, maybe it's the guys next door. I bet that's what it is. We're going to be fighting the whole class because there's another class next door and probably there's common controls for the lights. So services. Are there any services you're going to use today?
Education.
Oh, good. Very good. Education?
Food services.
Okay, so food services. It's not just the food itself, but there's someone who's preparing it. And I guess, in a way, all of these things have embodied services, right? Because there were people who produced them. So sometimes it's the service directly, like you're getting a massage and you're leaving and you don't have anything other than relaxed muscles. Or you're going to the doctor and they're looking in your throat and it was just maybe the diagnosis that you've purchased. So like maybe some of you will get medical services. I saw a statistic today that kind of shocked me. It was that right now, every day, they estimate 1% of the American population is getting infected with Omicron. So 1% new infections per day, which means right now between 5 and 10% of the population currently has Omicron because the usual course of the disease is between 5 to 10 days. So 5 to 10% of the US population is currently infected with Omicron. So I think that's maybe part of why medical services are a little bit overwhelmed, is that even though maybe not as many people are dying as they used to, there's still probably a lot of people going into the hospital asking for the new Merck pill or the new Pfizer pill or whatever, So medical services, let's continue this list just a bit more. What else are you using?
Utilities.
What's that?
Utilities.
Oh, okay, utilities. It's hard to say whether that's a good or a service, right? Like when you flush the toilet, well, the wastewater goes away. It gets turned into clean water that's dumped into the Ohio River. So let's say that's a service. And you know where your drinking water comes from, right? The Ohio River. Yeah, so you hope that the wastewater people and the drinking water treatment people did a good job. Okay, so how many of you could generate your own electricity if you needed to? Maybe for a little while, you got a little solar panel that will charge your phone or maybe a gasoline generator. But over the long term, it would be tricky to generate your own electricity. It would be tricky to grow all your own food. Maybe you could do it, like if you were a farmer, but you'd get awfully sick of eating soybeans. Or, most farmers are growing a monocrop. There's a corn farmer. Or maybe a farmer who's a dairy farmer. And, you could drink a lot of milk and eat a lot of beef, but eventually, I think the point that you're going to easily grasp is that all of the things you want to buy, you couldn't do by yourself. No matter how self-sufficient you are, you watch some of those survival shows and it's amazing. Like the really good people who can go up into the Arctic and survive, they make their own house, they cure their own meat, they'll gather berries and maybe even make a chair, something like that. But boy, it's an impoverished existence. It's such a small, narrow subset of the things that they have in their life that you've got in your life, like clothing, shelter, food, entertainment. You can't be self-sufficient. And that's part of what money is for. It's so that you can do your thing and people will consume whatever your specialized contribution to society is. And then you can get your payment for the thing that you do and spend it on the things that you want. It's a medium of exchange. So this is some of the tools that have been used over time as a medium of exchange. This is a sand dollar. In different societies they would use beads or shells as a medium of exchange. And of course there's disadvantages to using a shell for exchange. It was probably heavy. I'm not sure what a sand dollar was worth. What was the exchange rate? Was it one of these shells for a single meal? Or was it for an entire side of beef? I'm not really sure, but regardless, if you had to carry a canoe full of these around in order to make a purchase, that would be inconvenient compared to a wallet, which I don't have, except for I've got a payment on my watch, right? So that's pretty convenient. Electronic payments beats sand dollars or beads. Gold is a little bit more compact than sand dollars, you know, in terms of there's a lot of value there per ounce. Does anybody have an idea of what gold is right now per ounce?
$1,800.
$1,800, yeah. So a 1 kilogram bar of gold, that would be 2.2 pounds, which is what, about 35 ounces. So you're talking like maybe $70,000 or $80,000 for a gold brick. That's a lot. But if you're an Elon Musk type, it would be really tricky to move your wealth around if it was just confined to gold bars. And so paper money is even more compact and easy to move from person to person, especially if you consider, so let's say, okay, you've got that gold brick, it represents your life savings, and now you want to buy a cup of coffee. Are you going to take your pocket knife everywhere you go and shave off just a tiny little fraction of gold dust anytime you want to make a purchase? And then, so let's say you do that, and someone's paying you. You take the gold dust and you try and tamp it onto the gold bar. You'd have to melt it down every night to incorporate the new money. Very inconvenient. You get the absurdity of it, right? So paper money is more transportable. It is convenient because people can make change. Nobody argues that $1 is less valuable than another. If it was a sand dollar, maybe someone would say, this one's chipped. I don't want to take that sand dollar. It's not as good as this other one, which isn't chipped. Usually we don't have that problem with currency, although if you travel outside the United States, sometimes you'll notice that some countries have really nice money, like Australia has fantastic money. It has like these transparent windows in it, and the pictures are really vivid, and it's multicolored, whereas U.S., our money's just green. Other countries have colorful money where it's more than just a monochrome thing. And then there's some countries where the money's just, it's horrible because they don't put any cotton in the paper. So it's just kind of like normal paper. It's really thin and it wears out quickly. I went to Nepal a few years ago, and the money, you couldn't even really tell what the bills were sometimes. The money that you'd get back as change because it was so worn out. So the durability is sometimes a problem. Coins have a longer lifespan than bills do. I think the typical lifespan of a printed bill in the United States is just maybe 2 years, whereas coins have a lifespan of 20 years before they wear out and need to be replaced. Of course, there you get back to the problem again of it's getting heavy and inconvenient with the coins. So, of course, there's Bitcoin. And I don't know, when you see an article online about Bitcoin, they always show this. It's like, that doesn't exist. That is not a Bitcoin. And a Bitcoin is maybe more like a QR code, or it's an address where you can have money sent to you, and we don't need to spend a whole lot of time, but it's basically a public ledger where everybody knows how much value is in each address, and you have a secret key where you could sign a transaction to someone else. And a few years ago, I got interested in Bitcoin really early. In fact, and I kick myself almost every day that I didn't do more to mine. I mined a little bit, but just like a comically small amount, But I knew it was going to be cool. It's just I couldn't be troubled to figure out the miner and all that. So there's lots of different ways to keep track of value as a society. So what is money? Money is good as a medium of exchange. So that's just a way of transferring. For example, what I do is I do lectures, right? So that's how I transfer lectures into gasoline, or I transfer lectures into house payments. So it's a medium of exchange. A store of value is talking about how you can do work on one day and consume the fruits of your labor at a different time. You don't have to get the thing the same day that you do your thing. Like if I want to go on a cruise, I don't want to be lecturing the same day that I'm on the cruise. Or maybe I want a house now. I want someplace to live, and so I pay for that house now, so I do a big transfer of wealth, and then I'm able to live in the house for a long time. So money is a way of storing value. And think about retirement. If you were one of those really self-sufficient types who goes up to northern Canada and lives by a lake and you do your own thing, what happens when you turn 60 and you can't make your own log cabin anymore, or you can't wrestle down the water buffalo or something? When you get, what's that?
You make your son do it.
You make your son do it?
Yeah, that's about it, right?
Yeah. Or if you don't have kids, yeah, you're in trouble. You don't get to a ripe old age. So we have retirement here. So throughout your life, you contribute a little of money each pay period, and then you have this pot of money that you can draw on for the rest of your life, retirement. So store of value is a way of just time shifting obligations and time shifting when you get the fruits of your work. Unit of accounting is just a way to more easily understand the exchange rate between, let's say if you're going to be working as a software developer. One day of your time as a software developer, if you had to do just bartering, a society where everyone exchanges without money as an intermediate. So how much software developing would it take for a pile of firewood? Or how much software developing would it take for a hunting license? It'd be really tricky to know exactly how much your time is worth compared to what you want to get without this intermediate unit of accounting, the money in between, where you had a bunch of relative comparisons, where in your mind you could say, well, I know how much of this money it takes for me to get a meal. I spend $8 on a burrito, so maybe a chicken sandwich should be a little less than that, because you have all of these internal comparisons to draw. So money's really convenient in that sense. These are kind of textbook definitions of what money is for, the purpose of money. This fourth one, I saw someone make the point on Twitter recently that money is information, that it's a way of communicating not just among two people, but through the whole society. Like, how bees dance, and that's how they communicate to each other where the flowers are. Do you know how ants communicate? With chemicals, smells. They don't have a language. They don't really even have very good vision. I don't know if they have any vision. The way that they communicate is with smells. And so when one ant dies, for example, it gives off the smell of decay, and that's how the other ants know to carry it out of the ant colony and dispose of it. So money is a way of communicating need. And let me illustrate that with a little bit of a story. This past fall, I went over to France for a trail race. Trail running is one of my main hobbies. I really love it. And each August in France, in the town of Chamonix, which is like in the Alps, at the border of Italy, France, and Switzerland, they have a big series of trail races. And I've been over there several times before, and this year I was going to go do a race called TDS. And so it starts at 3 in the afternoon, and I expected it was probably going to take me about 24 hours to get through the course. And so, I went through the early evening. It started to rain a little bit. We got up into the high mountains, and it was cooling off. Got really windy. I got a little bit wet and chilled, but everything was going fine. You can see this is a picture of all the people with their headlights on as they're going up the mountains. Unfortunately, I got to a certain part of the course, and the race organizers had to stop. And so we're all just sitting around waiting. And it turns out that one of the other participants in the race fell down the mountain. He got chilled in the rain. His hands got cold when he was on one of the sections where you have to hold on to a rope. And he fell down the mountain, hit his head, and was killed. And so they made the rest of us just wait while they recovered his body, flew to the hospital. And by the time that was all sorted out, there was hundreds of people at the top of this mountain who'd just been waiting for hours for the thing to reopen. You could see that most of the people had deployed their emergency blankets. The race organizer require you to carry a certain amount of like emergency gear and warm clothes and stuff. I didn't get mine out. I was just marching in place, trying to keep my heart rate at about 100 to keep warm. So I was marching in place for 5 hours waiting. It was really boring. I ran out of water. But eventually they decided there was just too many people and they didn't want them to go through that same spot that the other guy had died on. So they said, turn around, you have to go back the other direction. And by then, since we'd been waiting so long, I was out of water and I was out of food, and it was 11 kilometers back to the village of Bourg Saint Maurice. And so I was just thinking, oh, this is going to be miserable. But then I remembered that about halfway between where we were and Bourg Saint Maurice, there's a castle. And when we'd been coming the other direction, uphill, there was someone at the castle who was selling Coke. And I wondered, I wonder if they're still going to be there. And they were. I got to that castle. Here's a picture of it. As I was headed back, I was just hoping that the people who were selling Coke were still at that castle, and they were. They were selling a can of Coke for €5, and that's about $6, and I was happy to pay it because I was totally thirsty. I don't know if I could have made it all the way to Bourg Saint Maurice. That caffeine helped because I'd been up through the night, marching in place, and so money was information there. It communicated the intensity of my need. The way that that person knew to go there is because they knew that they could make a big profit if they did. If they had been selling those Cokes inside the village of Bourg Saint Maurice, then I wouldn't have paid a penny for it because I just would have gone to a water fountain and filled up my bottles from that. But what they were able to tell, because of how much I was willing to pay, is how badly I needed the thing. So that told them where to go. The money told them what location on that course was going to be the most important place for them to be, because that's where I was willing to spend the most. So money is information. When someone's willing to spend a lot for something, that's a way of them communicating their intensity, like how much they want it. When you spend $1,000 for an airline flight the same day you're traveling, it's because you really need that. And the way that you're expressing how much you want that thing is by how much you're willing to spend. And so, price gouging gets a bad name. In an emergency, when people jack up the price of a water bottle to $5 or something. In a lot of cases, it's illegal. But that profiteering, sometimes, the person wouldn't bother to be where you need them to be if they couldn't make a large profit from their being there. So in my case, I was glad they were there, and it was great because I didn't need paper euros, but I did need a drink. So some of the characteristics of money is that it has to be durable. That if your sand dollars are getting chipped and broken, that's not ideal. These are like what we would prefer. The perfect money would be durable. It wouldn't wear out. The perfect money would be portable so that you can take it with you, and it's not really heavy. I showed you the pictures of those gold bars. Some people also use silver as money, but silver's less valuable. I don't know exactly. What is it, $20, $30 an ounce? $23 for silver. I've even seen on some sites that sell bullion and coins and stuff, you can buy copper bars. And so copper is even less valuable than silver and gold. And so I suppose there's some people out there who are stockpiling copper, but it's not very portable if you've got 1 kilogram copper bars, and that is going to be your store of value. So ideally what you would want is your money to be portable and dividable so that it's easily broken up into smaller denominations. You can break 100, although maybe the cashier's going to roll their eyes. Usually you'll be okay with a $100 bill, but that 1 kilogram gold brick is less divisible. One of the problems with Bitcoin right now is that in theory it's divisible to, like 10 decimal places in theory, but the transaction fees are so high that you couldn't pay for a cup of coffee with Bitcoin. Maybe you could using one of the secondary layers like Lightning or something, but just like the straight normal Bitcoin network, the transaction fees are really high, like $20, $30 to make a payment is what the fee is. And so it's not very dividable, not in a practical term. One of the reasons why Elon Musk likes Dogecoin is because the fees are so much smaller. So micropayments are more of a possibility with some of these new alternative coins. One of the important characteristics of money is that it's uniform. So just that your dollar and my dollar are equal, and some dollars aren't considered suspect. And you know, when we have a central bank that's printing the money, that's fine. But if there were different banks, maybe you'd be less happy to accept a Chase Bank dollar than a Fifth Third Bank dollar. And that used to be the case, that different banks would issue their own notes. Sometimes they're called bank notes. And so different banks used to issue their own notes, and even though they'd be for the same unit, you know, like pounds sterling, if it was a British bank, you know, it would be a certain bank's issue of pound sterling notes, but because some banks were more trusted than others, the notes weren't all traded equally. And so that was an inefficiency, the uncertainty of that. So ideally, we would want it so that the currency is uniform and all of the units are equal to each other, as long as it's a $1 bill being compared to a $1 bill. Of course, limited supply ideally is what you want. And one of the big criticisms that US dollars have gotten, especially in recent years, is that the Federal Reserve keeps printing more and more dollars. And I'm sure you've probably seen pictures of what happened in the I guess it was the 30s in Germany when they had hyperinflation. What are the pictures that you've seen related to that? What's a classic photo?
Barrels of money being used to keep warm.
That's right. People carrying around wheelbarrows of money. It was so worthless that they'd burn it to keep warm, or you'd have to have a whole wheelbarrow worth of money to buy a loaf of bread when they printed too much of it. So one of the big things that cryptocurrencies have in their favor is that the supplies really are limited. I think there's only ever going to be 23 million Bitcoin. That's a hard cap. There's not going to be more than that. But as far as US dollars, I think what I heard is that there is, what is the statistic? Something like 3 times as many US dollars in circulation now as there were in 2008. So the pool of money is much, much greater than it used to be. And finally, ideally, you'd want money to be acceptable wherever you go. And you probably noticed on currency it says it's legal tender. And I think that businesses are required to take US dollars. Like, there are some places that don't accept cash, and sometimes they get in trouble because they're not accepting cash, and you're obligated to take cash if you're operating a business. But ideally, you'd want it so that the money is accepted everywhere. So these are the characteristics. Now, what should you be doing right now, by the way? It may be that Dr. Zatar will provide you with the notes, but it wouldn't be a bad idea to write some of this down. I know that he's got a few exams on the schedule, and he may draw questions from even the first day of class. So these are characteristics of money. By the way, I'm recording this lecture, and I'll post it on my YouTube channel. I don't know if Dr. Zatar is going to record his lecture. Most professors don't. But I record all the lectures that I give, and so if you're now kicking yourself for not taking notes earlier, you can check on my YouTube channel later today and maybe just fast forward to this one and copy it down. Okay. Any questions about the characteristics or any comments about this? I love money. I love it so much. I just think about it all the time. I love it more than my children. No, that's not true. It's a joke. So part of this course is to learn tools that will allow you to compare alternatives. So computer science majors. Part of the reason why you're in this course is that your profession has aspects related to money. Like, even if you don't go into financial services, you're going to get paid, and your company is going to get paid, or your organization will have a budget. Your organization is going to buy things, and you're going to have to make decisions. So just as an illustration, you could be looking at, should you buy a small asphalt roller or a big asphalt roller? And bigger is always better, right? Except for when it isn't, like when it's more expensive, or maybe when it breaks down more, or when it's overkill. Like if it's a bigger thing than you need, then bigger's not better. So part of this course is going to teach you some techniques you can use to compare whether it makes more economic sense to buy the big thing that's more expensive or the small thing that's less costly. So you're going to learn some analysis tools for making decisions. Decision making is a really important part of this course and also part of an engineering or computer science career. Comparing alternatives and knowing which one is best. And as far as like 10,000 foot view, like the introduction of what we're doing here today, you're learning about the time value of money. And this phrase, time value of money, is tied to the idea that money now is more valuable than money in the future. So think about if that's true. Like in your own life, have you noticed that trend that the future seems like money is less valuable than it used to be? You probably heard stories from your parents, I bet. Have your parents ever told you how much gas cost when they were in high school, that kind of thing? I remember that when I started driving, you could get gas for like $1.29, $1.39. Candy bars is another popular one. I remember my grandparents telling me about how you could buy a candy bar for 5 cents. Of course now, maybe you could get a candy bar for 50 cents, but more likely you're going to go with king size, right? So that's $1.50 at least. So time value of money. Money now is more valuable than money in the future. So just as an illustration, this is what's called a cash flow diagram. That's one of the things Dr. Zatar is going to teach you about this semester, is ways to set up problems. Like sometimes it's a word problem, and it will make more sense if you sketch it out. Like if you make a graphical representation of what's happening. So this is saying the arrow down means you have to pay. If it was an arrow up, that means you get the money. So this is saying you have to pay $8,000 now. Or you have to pay $4,500 2 years in a row starting 3 years from today. So remember in the previous slide I said this course is partly about choosing from among alternatives. Sometimes the alternatives is physical equipment, like you're trying to figure out if one server is better than a different server, or maybe one piece of equipment is going to generate more cash for your company than another. Sometimes it's this, and sometimes it's strictly financial decisions. So just as an illustration, which should you prefer? Should you prefer to pay $8,000 now as a lump sum today at time 0? Or should you prefer to pay 2 payments of $4,500 starting 3 years from now if the applicable interest rate is 8.5%? We haven't talked about interest yet, and we will. We'll talk about interest today. But just to give you an idea of what this course is all about, and to give you an idea of what is the time value of money, let me show you how we could solve this one. I'll solve it 2 ways. Oh, I didn't bring a marker. All right. Anybody have a marker? Sometimes you students really, save me. You've got one. I'll take it. Thank you. All right. So $8,000 now. The wrong way to do this comparison is this. Here's the wrong way. I shouldn't even be showing you the wrong way, but probably you already know what the wrong way is. 2 times 4,500 equals 9,000. That's the wrong way. Now, why shouldn't you do it that way? Any guess on why that's not the right approach? Go ahead.
Do you have to do interest on both of the 4,500 individually?
You have to do interest on both of the 4,500 individually. That's right. Other thoughts? Remember what I said is money in the future is less valuable than money now. So this $4,500 in year 3, things are going to be more expensive 3 years from now. think about how prices have gone up just in the last 1 year. Does anybody know what inflation has been in the last year? 6.9%. The average cost of goods and services in the U.S. has gone up 6.9% in the last 12 months. Some things more than others. Energy is more expensive than it used to be. Water is more expensive than it used to be. Some food. I've noticed it at restaurants. Some places have printed new menus and conveniently new prices as well. So in the future, this $4,500 is going to be having to buy things that are more expensive than those same things are today. So that's what interest is all about. It's kind of like if you're going to have to wait to get your money back, you want a little extra. So what we have to do is we have to take that $4,500, which is in the future, and find out how much is it worth in today's terms. So we're going to take it backwards in time. We're going to take this money and time travel it. Well, not really. It's not time travel. It's just finding the present equivalent of it. And there's a formula. The formula is future is present times 1 plus I to the n power. This is a preview. I'm sure Dr. Zatar will give you this equation again in the future. But I think it's valuable for you to see it now just to get an overview of what this class is even about. Okay, so future is present, 1 plus I to the n. Another way of expressing this is that the present value of a future amount, does somebody else have a different marker? This one's starting to lose its steam. Even better, thank you. Appreciate it. All right, so present, we're just doing algebra here, is future divided by 1 plus I to the n. Does everybody follow me so far? We just rearranged that earlier equation. Okay, so let's find out $4,500, 1.085 to the power of 3. So this is going to tell us how much the $4,500 in year 3 is worth if we move it back in time and find the present equivalent of it. So if you've got your calculators today, bless you for that. Calculate this with me. I've got my calculator today on my phone. I've got an emulator, a Hewlett-Packard emulator. 4,500, okay, and 1.085 to the power of 3. So down in the denominator, this one down in the denominator is 1.277289 ... and so on. Okay? So the 4,500 that was in year 3 has a present equivalent of 3523.09. Okay? So that's just this one first payment. Let's find the second payment. So this is year 3. And so then year 4, the present value P is 4,500 divided by 1.085 to the power of 4. Okay, so again, we're on the calculator here. 1.085 to the power of 4. So this denominator factor is now 1.385, etc. And so the 4,500 divided by that is 3247.08. So think about this. What it's saying is that $4,500 4 years from now has a present value of $32.47. $4,500 3 years from now has a present value of $35.23. So the further it is in the future, the less valuable it is in today's terms. Does that make sense? Money really far in the future isn't very valuable in today's terms because we know in the future prices are going to be higher. So the purchasing power of each individual dollar is lower in the future than it is today. So the present value, if we add those two things together, the present value is, so the sum of the 2 years, PV, present value, is 6770.17. So which should you prefer? Should you do the lump sum, or should you make the future payments?
Future payments.
Yeah, do the future payments. It costs you less. If you do the lump sum now, you're out $8,000. If you delay making the payments, what this basically means is if you put 6770, if you put 6770 in the bank, and your bank was paying 8.5% interest, you'd have enough money in the bank to make those payments in the future. So that's just another way to think about it, is that you can either pay $8,000 now, or you can pay $67.70, put it in an account that's earning interest, and then you'll have enough money to make those payments when they do finally come around in years 3 and 4. Okay, so any questions about that example? How many people here have used Excel before? Raise your hand if you've used Excel. I love Excel. If I was stuck on a desert island, Excel is the software I'd want. Because on this desert island I've got a computer, and Excel is my spreadsheet that I would use. You're going to get really good at Excel. Let me just show you how we would solve this in Excel. We would translate the cash flow diagram into a cash flow table. So here at the top, I'm going to have I, define my interest rate, 0.8085. And then I'd have year, amount, and PV of amount. Dr. Zatar will teach you all this stuff. 0, 1, 2, 3. So I'd translate each row in the cash flow table into an amount. So the first time we see anything is an outflow in years 3 and 4. So there's nothing happening in present time, nothing happening, and then negative 4,500, negative 4,500. And then nothing happens again. So this is the amount in the year. This PV of amount is going to tell me what's the present value equivalent of those future amounts. All right, so I'll do this function equals PV. Excel has all these functions built into its memory, and one of them is how to find the present value of future amounts. So once I start the function, it's going to give me these little prompts here, these clues of what it wants to know. So first of all, it wants to know the rate. I don't know if you can see that in the back, but it says rate. And so what I do is I just click in the location where the rate is typed. I could type it into the equation, but I could also just click in that spot. Okay? Now I just pushed F4 and it gives me those dollar signs, and what that means is it's always going to look in that spot. Even if I move the equation around, it's always looking in the same spot. Okay, so then the next thing it says is N. Like how many periods, NPER, the number of periods in the future. So that's basically the year that you're in. So I'll just click there. And I'm going to skip over this payment field, and now it says FV, future value. So it wants to know what amount is it in the future you're trying to find the present equivalent of. So I'll just put that amount there. And then if I drag this formula down, it calculates the same numbers that we had gotten on the board. 352309, 324708. It's in red because it's so annoying. It does that formatting. I prefer it not like that. The minus sign. Instead of it being red, you know, accountants use red to mean that you're losing money. If you're in the red, they say. Okay, so then we add it up. Sum. And 67.70 and 17 cents. So that's the same that we've done by hand. So you're going to learn how to solve these types of problems using equations. In the back of the book that you're going to buy, it has lookup factors where you don't actually even have to solve these equations. You can just look up like this factor, 1.385, that sort of thing. They have those in the back of the appendix in your textbook. And you're also going to learn how to solve problems like this on Excel to account for the time value of money. So any questions about the example either on the spreadsheet or on the whiteboard? Time value of money. Money in the future is less valuable than money now because in the future there's going to be more dollars in circulation. And so there's more money out there, and so it means that prices are going to be more expensive in the future because the rate of money expansion is greater than the rate of how quickly the number of products is expanding. So inflation, prices are increasing constantly. Why is money less valuable in the future? It's partly because things are more expensive then, and then the other way to think about it is the money now, you could buy things that cost less. So if you wanted to, anybody heard about the new Ford Maverick? It's a truck Ford has. It's a really inexpensive truck. They're selling it for less than $20,000. It's a hybrid, so it has really good gas mileage. I guess you could say it's not even a truck if it's got a hybrid, right? But in any case, it has a lot of interest, but they're going to have to start charging more for it. $20,000, that's not going to be the price in the future. And I'm almost tempted to buy one now. I don't need a truck, but it's just so cheap. How could I resist, you know? So because things are going to be more expensive in the future, that makes the money less valuable than money now, each on a dollar for dollar basis. Now, when you take out a loan, a lender is going to want more money in the future to account for the fact that the money that they loaned to you today was more valuable than what you're paying them back with. So that's part of the reason why interest exists, is because future dollars are less valuable than present dollars. So let's talk a little bit about interest. Interest is one of the side effects of the time value of money. And whenever you hear this phrase, time value of money, what you should just think of is money in the future is less valuable than money today because of price inflation. That's the translation of this phrase. It's the practical implication of that phrase. So interest, you can think of it as just how much extra you have to pay to the lender. And the lender is getting extra money in part because you're paying them back with something that's less valuable. It's like if your neighbor borrowed your tools, and when they return it to you, it's going to be all worn out. Like if they borrowed a drill and your drill bits, and they return it to you and your drill bits aren't sharp anymore. Well, what if they gave you two drill bits back that are like kind of sharp? I guess maybe that would be okay if you got more back, even though it wasn't as good. That's what happens in a loan. When you pay back a loan, the dollars you give them aren't as good as the dollars they give you because dollars don't buy as much stuff in the future as they buy now. So part of the remedy to that is you have to pay the bank back more in the future than they originally gave you because of that time value of money issue. So if interest is in part compensation for the delay, of course it's also compensation for risk. What do you think, in the view of the bank, what is the risk of loaning someone money? What risk is the bank worried about?
Not getting paid back.
Not getting paid back. That's the number one risk they're worried about, is that you're going to default. Maybe you lose your job and you can't pay it back. Or maybe you just don't want to. You know, you just, I'll buy a bunch of flat screen TVs and declare bankruptcy. So those, the default risk is part of what they're worried about. Another risk that they're worried about is something called interest rate risk. Like what they're worried about, the bank, is what if you borrow a bunch of money from them and you promise to pay back at 3% interest rate, which is kind of about a typical interest rate right now for a mortgage loan, 3%. But then what if suddenly all around you interest rates go up, then the bank is stuck having loaned you money at 3%, and now all the other loans they could have made, if they hadn't done that to you, they could have loaned it out for even more money to somebody else. They could have got, in other words, a better interest rate for someone else. So interest rate risk is another thing that they're worried about. So they want compensation for this fact that they're getting paid back in the future. So the difference between how much you pay them and how much they gave you, that is interest. So if we're going to do it as a formula, interest is the amount that you owe after some time has passed in the future, minus the original amount that you borrowed. So minus the principal. Interest is the difference. And if you express it as a percentage, then that's interest rate. So the interest amount divided by the original principal amount multiplied by 100 would be the interest rate as a percentage. Here's the formula. The interest amount divided by the principal multiplied by 100 is the interest rate. Now, interest and rate of return, those two terms can sometimes be used interchangeably depending on whose perspective it is. If it is the person who's borrowing money, they think of it as interest, but the person who's loaning money thinks of it as a rate of return. So in this course, sometimes those two terms are used interchangeably when you're doing time value of money problems. Sometimes it'll say the interest rate is 3%, and a different problem on the same assignment may say the rate of return is 3%. And it doesn't matter if it's interest or rate of return, the calculations are the same. You'd put it into this variable I. When you have given the interest rate as a percentage, then you can calculate the future value or the present value. So this diagram is just to make the point that interest rate and rate of return are basically the same thing, just it depends on whose perspective is being represented. Okay, now I've been talking for nearly an hour now, 52 minutes. You need a break. I definitely need a break. So what we're going to do is a couple of in-class exercises. I've got 3 problems I'm going to hand out here. Let me bring them up on the screen just so that they're integrated into the recording. Here are the 3 problems. I'd like you to work with your classmates and see if you can figure these out. The first 2 are pretty easy. The third is a little bit more complicated, but I'm sure we can get there. And the formula that you're going to need is, maybe write this formula down, this one. As I hand out the papers, be sure that you've got this formula in blue written down. It'll be a good chance for you to meet some of your classmates. It's good to be social. It's good to find a study buddy. It does not need to be quiet in here as you work on these problems. In fact, I prefer that it's not. I prefer that you're real chatty and gregarious and work through these as noisy as you like. So you'll have 15 minutes to work on this, and then we'll get back together to look at the solution together, and then I'll hand out the syllabus and talk about that a bit. And I have the solution. If you want to check your answers, I'll tell you if you got it right, and I'll bring the solution up on the screen as well towards the end. That we're all on the same page with problems 1 and 2. Let me bring up my scan of the solution. All right. So here's problem number 1. So the amount you owe in the future is the principal and the interest. So the principal is the original amount. We're just defining terms here. So the original amount was $20,000. The interest is 5% of the original amount. That's the definition of interest. It's the interest rate multiplied by the principal, and that gives you the interest amount. So we calculate the interest amount by the 5% rate, and 5% means 5% of the principal is how much you have to pay as interest. So in total, you owe $21,000 at the end of 1 year. Easy enough, right? All right. Question 2, what rate of return will you earn if you invest $200,000 in 1 year, they pay you back $212,000. So we're just going to define the terms here again. The principal is $200,000. The interest is, by definition, like the definition of interest is the difference between what you pay back and what you got. So the interest amount you can see is $12,000. And even if this stuff is really simple, I think it's a good habit to get in to write all of the steps of the problem. Because number one, it's good for you to review in the future to see all like what the steps were. But then the other part about it is, let's say if it's an exam and you accidentally make a mistake, if you show your steps, you're going to get some partial credit. But if you just have the final answer without showing your calculations and all the assumptions you've made and stuff, then you're going to be a lot worse off. Okay, so then the rate of return, the definition of that is the interest amount divided by the principal. So that's the formula that we had here. Oh, that looks weird. Something changed. Interest amount divided by principal multiplied by 100 gives us interest rate. So any questions about problems 1 or 2? Okay, problem 3 is more tricky, right? Like these are both relatively straightforward, but problem 3 is a little bit tricky. Let me give you a hint on this one. So AED, that just means United Arab Emirates dirhams. That's the currency that they use in Dubai. And then Icelandic krona, that's the currency that they use in Reykjavik. So let's say that today you've got 55,123.45 in Peter's savings account. So this is how much Peter has after having earned interest. So it represents the final. So what we want to know is the before. You know, a year ago, how much was it? So these calculations we've been doing so far. Can I use that marker again? I should have given it back already. Thank you very much. All right. So, amount after 1 year is the original amount plus the interest. Okay. So does everyone agree with this first formula that's on the board here? After a year, the original amount plus the interest. Okay. Could we break the interest, I should say interest amount, to differentiate between, you know, there's two different things. There's interest rate and interest amount. What's the formula for interest amount?
Interest rate times the principal.
Good. Exactly right. Interest rate times the principal. We'll call that the original amount, since I used that phrase here. But original amount, that means principal. Okay, so interest rate times original amount. Okay, so here's our formula. Amount after 1 year is the original amount plus The interest rate times the original amount. Okay, so in this problem, what's the unknown?
The original amount.
The original amount is the unknown. Classic variable, x. All right, so the amount after 1 year is 55,123.45 ISK. Let's do, first of all, we'll do the time conversion first, and then after that we'll do the currency conversion. We could do it the other way and it would be fine. It wouldn't matter. You could do the currency conversion first and then the time conversion, but this problem has both. It's got a time conversion and a currency conversion. Big deal. We'll figure it out. So 55,123.45 equals x plus interest rate times the original amount. What's our interest rate? 0.03 times x. All right, so that's the hint. It's a pretty big hint, but that's the hint. All right, so I'm going to pause, allow you to keep working, chat amongst yourselves. So you're going to do the time conversion and then do the currency conversion from krona to dirhams. All right, let's look at the solution to problem 3. So there's a couple of different ways to solve this. There always is more than one solution method. So you can see I started off with the currency conversion first in this one. But the basic structure of the problem is that you're finding this future amount is the principal plus the interest. And so what you should get in the end is that it's 1,518.24 AED, which is United Arab Emirates dirhams.
Oh, I had that earlier.
All right, so the other way to do it, I've written here on the whiteboard, F equals P times 1 plus I to the n. So n is 1 year, I is 0.03, and you know the future amount, and you're solving for P. So, you're wanting to find out how much was the original amount before the interest was added. Because this amount that it says here, the 55,123, that's how much money is in the account after the interest was added. Okay. So what I'm going to do now is hound out the syllabus. It's 12:13 and I never keep students late. So what we'll do is I'll give you this now and we'll discuss it at the beginning of the lecture on Thursday. So please look it over and be ready to discuss.